This is scheme of our device trigger. One takt synchron trigger. We have three inputs: set, first input, second C, syncron, and third R, reset. And we have two outputs, non-inverting and inverting. This is our equalities, yes, our output, non-inverting output, and this is our inverting output. We see that our non-inverting output equals CS and our memory, and this is parity of our non-inverting output. When we give switch C 0 and change values of R and S inputs, not matter that what voltage we give R and C S. If we give input C 0, it's our device works that and add our voltage to the memory. It's memory region. If we give 1 to C input, and when we give 0 to R and S inputs, we have memory region 2. And if we give 1 to C and 0 to R and S to C, S2, and we give S input S1, we have non-inverting output 1 and inverting output 0. And then we give C1, R1, S0, we have non-inverting 0 and inverting 1 outputs. We can't give C, R and S in the same time, both of them. We can't give 1. It's equals our non-inverting and inverting outputs equals 1. And this is this regime not permit us to give in the same time to our inputs 1. Let's see our device, this device in real scheme. And I assemble our real scheme. This is first LED and second LED. This is our second LED. This is our second LED and is inverting output, and which LED is light is non-inverting output. This one is our switch 1. By this switch we give to C, S input high voltage, switch R and switch C. Each of switch I connect like this LEDs. When we give high voltage to inputs, our LEDs starts light, and we understand that we give high voltage to our inputs. Let's check our inputs. We give our inputs low voltage because our LEDs not lights. It means that we give three of our inputs low voltage. We have memory region. Our inverting LED starts light, and our non-inverting output LED. Of course, our LED starts light and our inverting output not light. When we change our RES, change our S input, we give high voltage to S, our memory region not change. And when we give high voltage in R2, our output not change yet. And we can change our R and S. Our input not change its memory region because we give to input C 0. We change values of R and S, and when we give one high voltage to C, we give high voltage to input C, we see that our non-inverting output not change because our R and S inputs, both of our R and S equals 0. We don't give high voltage to R and S. Okay, we have in input C high voltage. We see that our non-inverting output not change because we have low voltage in S and in R switch. In our inputs we regularly change switch S. We give to input S high voltage. Our LED starts light, switch LED, but our output not change because we have non-inverting output high voltage. Then we let's change switch R. When we change switch R, we give high voltage to switch input R, and our outputs change. We have in output non-inverting output 1 and non-inverting output we have 0, and in inverting output we have 1. Let's change our R and S both together. We give R and S together high voltage. We see that our outputs, both of our outputs, LEDs starts light, and this is not permit to us give in the same time to R and S and C high voltage.